Lesson 3.5, Energy in Humans and the World. Human bodies, and in fact all living bodies, convert energy. They take the food energy and convert it into work and thermal energy and chemical energy and stored fat. The rate that the food energy is used is called metabolic rate. Basal metabolic rate, or your base metabolic rate, is the total energy conversion when you're at rest. The different organs in your body use this energy at different rates. The highest is your liver and your spleen. Use the most energy while you're at rest. Table 7.4 lists others. So your next highest would be your brain, and then your muscle and kidneys, then heart. They all use energy while you're resting. And then table 7.5, if you're not just resting, then and you're doing activities, you get a higher metabolic rate for the time that you're exercising. So sleeping then would be the lowest amount of energy use. Sprinting is by far the highest. And just in general, the more pressing activity you do, the more energy is used. Energy is important because it's required to do work. Worldwide, the most common source of energy is oil. And so this is from a few years ago, but it hasn't changed much. So petroleum, or oil, is by far the biggest use, followed by coal, followed by natural gas. So that is the biggest pieces there, and that accounts for almost 3/4, or well, looks like more than 3/4 of the world energy use is fossil fuels. Problem with that is, of course, we can run out, making them far more expensive. They're polluting. They're kind of a mess to get to. The useful things about fossil fuels is they're very energy dense. There's lots of energy in a small amount. We have our renewables. So these were the fossil fuels. These, well, I guess not nuclear, but nuclear is far more efficient. Hydro, so that's dams across rivers. They produce electricity as long as there's a drop in the water. So that's converting gravitational potential energy in the water as it falls down and converting it into kinetic energy in a turbine, and that then makes the electrical energy. Problem with that is the dams block up the rivers, so then it changes the ecosystems. We have reservoirs, big ponds or lakes behind the dams, and then we also stop the fish from going up the rivers, like the salmon or the trout going up to spawn. Nuclear energy. Nuclear is very efficient. It uses heat from nuclear reactions to boil water to turn a turbine to create electricity. The problem, of course, is if there's an accident, then we release radioactive material, and that is, well, generally bad since it causes cancer. We also don't know what to do with the waste product after the fuel is spent, although they are creating new types of reactors that use far more of the fuel than has in the more traditional reactors. Geothermal, wind, solar, biomass, those are all renewables used to make electricity. So geothermal is heat coming from the earth. Wind blowing a windmill, solar panels. Biomass is burning things like wood or grass or things like that, living matter. Notice how small of a segment that is when you put it all together. And then you have the same thing but not used for electricity, just straight for cooking or heating. The USA has a population of about 4.5% of the world population, but it uses 24% of the world's oil. What? Doesn't seem fair. Well, we've got the money to buy it. We also have the land to produce it. The energy or the military might to control it. World energy consumption continues to increase quickly, hence the price of fuel keeps going up very quickly. The price of energy in general keeps going up quickly. It's because China and India, their economies keep growing. There's a lot of people there, a lot of manufacturing. So they are taking a bunch of the oil and coal and stuff and using it themselves instead of letting it go elsewhere. So the competition raises the prices. The fossil fuels, of course, are very polluting. They pollute, cause the greenhouse gases are released, carbon dioxide, and so on. So many countries are trying to develop renewable energy sources like wind and solar. Europe is leading the world, I believe, in this. They have many, many wind and solar projects. They've, I believe, are working on nuclear also. They're trying to get as little reliance on oil as possible, mainly because there's not much oil in Europe. So they need something else. The world's falling apart. Wars and stuff being fought over the oil. So they would like to just be out of all that and just rely on their wind and solar. The U.S., many places in the U.S. are trying to develop the wind and solar, but it's hard because we do produce much of our own oil and coal. So it's we have these resources, so it's hard to convince people to give up those resources that are so easy to get in exchange for more expensive, unreliable energy sources like wind and solar. Wind only works when the wind's blowing. Solar only works, well, when the sun is out. Up north, here in the winter, the sun isn't out very much. So solar isn't so great. In general, throughout the world, higher energy use per capita means per person. More energy per person means a better standard of living. Most of the energy is used U.S., Europe, Japan, China, and so on. So the more energy you can use, the more energy you can spend. Energy is essentially money. If you can control the energy, you control the economy. If you have better economy, better standard of living. Near where I live, there is a large wind farm called it's near Ludington, so it's Ludington Wind Farm. And like I said, wind is not reliable. It works great when the wind's blowing, but when it's not blowing, what happens? So they have developed a way to store this wind energy. It's called the Ludington Pumped Storage Power Plant. It is a reservoir 110 feet deep, 2.5 miles long and 1 mile wide, which holds 27 billion gallons of water. It's a reservoir. It's located on the banks of Lake Michigan. The power plant is 6 reversible turbines that can generate 312 megawatts of electricity for an output of 1,872 megawatts. At night, when there's low demand for electricity, the turbines but there's extra electricity in the grid from the windmills. The turbines pump the water up from Lake Michigan, 363 feet up, into the reservoir. So they are increasing the potential energy. So they're taking this electrical energy and converting it into potential energy in the water. It's like a big battery. During periods of peak demand, water is released, goes through the turbines, and electricity is generated. So there, the potential energy is being converted back to electrical energy. And so this is designed to level the load of nearby nuclear power plants and the wind power plants, and to make your energy level nice and level so that the electrical grid works well. So it is really a big battery storing electricity as potential energy that then can be released and used later.